Okay, good afternoon, everybody. Only 14 first participants so far, so let them come, then I will start.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon. Can you see the screen what I have shared right now?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So, as per the previous discussion, I have told that today I will show you how the subtraction perform in the computer. So, before the binary subtraction we'll discuss, it is essential to understand that how computer represents the negative number. Without knowing that, you cannot understand or I cannot go ahead the subtraction purposes. So maybe subtraction will be completed by today or it can be get back to that to the tomorrow because first you need to know the negative number representation. Okay, so let's start with the today's discussion.
Sir, I couldn't hear what you said. Can you just repeat?
No, I am just telling that first we will study that how computer understood the binary negative number, then we will discuss the subtraction logic. Okay.
Okay.
So let's say we are going to subtract b from a. So we can rewrite that statement a plus minus of b, right? So what we actually do, we are actually doing to represent b as a negative number. After that, we are going to add a with b. Then also we will get the precise subtraction result. Now, how the question comes first, how computer represent negative numbers. So there will be three types of mechanism through which computer represent negative number. One is the sign magnitude. Next is the ones complement. Just take as a name one complement, and last one is the twos complement. So there will be three mechanisms through which computer represent the negative number. So what sign magnitude says, so there will be dedicated bit for a sign number. So before proceeding to this, you need to understand what is an signed number and what is an unsigned number. So in general example, when we write 10, as our mathematics, we always assume that this is a positive number. When we write minus 10, then we can assume that it is a negative number. But once you have converted 10 into decimal, 10 into binary, when you convert the 10 value into binary, then how to represent minus 10? If 10 is there, so 10 is 1010. But how you can tell the computer whether it is a plus 10 or minus 10? The first methodology is the sign magnitude. So in 10, it is required to get total 4-bit area in the memory. 1, 2, 3, 4. So 1010, 1010 will be put here. Now you know computer memory comes with 2 to the power n factors. That means you can have 1 bit, that is 2 to the power 0. You can have 2 bit, that is 2 to the power 1. So in this way, computer blocks are growing. So I am assuming that there is an 8-bit memory is being there. The memory size is 8-bit. Now the leftmost bit, I am making this leftmost bit as yellow. So this is reserved for sign. So this is the leftmost bit reserved for. Now what is the rule for this? So in the last or the leftmost bit, either it can have 0 or either it can have 1. If it is filled up with 0, then computer will assume it is an positive number. And if the yellow bit is treated as an 1, it will be called as a negative number. So if we want to represent plus 10, what should we do? We will write 4 zeros, 1010, because we cannot use 5-bit because computer doesn't support. Computer only supports in the 2 to the power n ratios. And if we are going to establish minus 10 in computer, what we did? So we will do like this. So this one last one, it is not the magnitude of the value, it is only for sign. So this ensures the computer that this is a positive 0 and this is a negative 0. And the remaining part I am make as an pink sign. For pink the visibility is less, so better to use sky blue. This sky blue color is actually the magnitude. The sky blue color is the magnitude of the number, that is the value. And the yellow section tells us the sign. Understood the sign magnitude part? Yes or
হ্যাঁ
no?
স্যার, বুঝতে পেরেছি। তবে স্যার ওই এটা তো 8 বিটের ক্ষেত্রে এরকম হবে স্যার, কিন্তু অন্যান্য যে বিট আছে যেরকম 4 বিট আছে, 2 বিট আছে, এগুলোর ক্ষেত্রে স্যার কীভাবে হবে?
In 4 bit you cannot represent -10 because to hold the magnitude you require 4 bit. So you cannot no space left for the sign, right? So
Yes.
any number, if you take 2 as a decimal number, so if we represent 2, what will be there? 10. So if you take 2 bit, the 2 bit is already occupied by the magnitude. You have to take 3 bit, but 3 bit is not possible. You have to take 4 bit. So this information you have to keep 0. This is the sign bit. And this is the padding bit. So there is no use. Actually, we will see 10 as a magnitude and we will get 0 as a sign, that is a positive number. But the same thing when we comes to 4. In 4, the representation in magnitude is 100, that is 3 bit. So if we figure it out into the memory, so first from the right hand side, first 3 bits will be occupied by this one, and if you represent the sign we have to put 0 in the remaining bit. Now understood?
ইয়েস স্যার।
স্যার
স্যার আরেকবার বুঝতে পারলাম না।
Take any number. তুমি একটা নাম্বার অ্যাজিউম করো, বলো। 8. So if you are going to represent 8, so what is the structure of 8 in binary? This is. So to represent 8, how many bits are required? 4 bit. In 3 bit you cannot represent 8. So if you want to introduce sign plus 8, so you have to keep a space for sign. So where you should keep your place? So if this is the 8, so you have to an additional space. Additional space means 4 plus 1 is 5, but 5 is not allowed. You have to go 4 to 8, 8 to 16, 16 to 32 in this fashion. So I am taking some additional bits. So in the additional bits, in the leftmost bit, the leftmost bits I have put as 0. So this bit will check by the computer as a sign bit. It will be not a part of the magnitude. The magnitude part is 0 0 0 1 0 0 0 0. So that is gives you 8, and is 0 gives you plus. So together it will become plus 8. Now understood?
আচ্ছা স্যার, মেমোরিতে ওই রকম বিট কি করা থাকে?
Memory is nothing but a set of blocks, and each blocks will take a particular 0 and 1s, because computer only understands either 0 and 1s.
স্যার যে নাম্বারকে স্যার ওই 8 বিটের মধ্যে লেখা যায় সেই নাম্বারকে যদি আমি 16 বিটের মধ্যে লিখি তাহলে স্যার কি ভুল হবে?
না, ভুল হবে না।
ওকে স্যার।
Total 16 bit means first 15 bits for magnitude and leftmost bit for sign. That you have to maintain. Okay, understood? Any question? Any question from your end? So sign magnitude part, I hope it is clear to you. Next part comes to the ones complement. ones complement. Ones complement is nothing but toggle each bit. Toggle each bit. What do you mean by toggling? If it is
So the
8,
value will change rapidly from 0 to 1 and 1 to 0.
yes, right. So if it's 8, so 8 means 1 0 0 0. If you take ones complement, in this way we write ones complement of 8 will be 0 becomes 1, all zeros becomes ones and ones becomes 0. That is called the toggling. So ones complement of 8 will be 0 triple 1. Okay. So once, but through ones complement we also represent negative number. In ones complement we also represent negative number. Okay. What is two's complement? If this is 8, sorry, two's complement first, see the thing. Two's complement means one's complement plus 1. One's complement plus 1. That will become the two's complement. So if this is 8, it will 1 0 0 0. So after completing the one's complement of 8, what will have get 0 1 1 1. And if we add a plus 1, then what will be the value? Tell me the addition. Addition I have already discussed in the previous class. 1 1 0 carry 1, 1 1 0 carry
Yes.
1. So what we get? Right? So that will be the two's complement of 8. So this is also used for negative number representation. Now the question is, what should we use?
স্যার একটা জিনিস বুঝলাম না স্যার, ওই নেগেটিভ নাম্বার রিপ্রেজেন্টেশনের জন্য ওয়ান্স কমপ্লিমেন্টের টুস কমপ্লিমেন্টস কিভাবে ইউজ করা হয়?
No, actually you have to tell the computers that which one is positive 8 and which one is negative 8. So you have three options to do. You can use one methodology, that is sign magnitude, that is the leftmost bit you can make as a sign and unsigned or positive or negative, or you can use one's complement. So if you put this to the computer will understand that this is a negative 8. If you put this one to the computer will understand that it is a negative 8. Now the question is, three methodology we have. So which methodology we should follow? That is a big question. So all modern digital system uses two's complement to represent negative number. All modern digital system uses two's complement to represent negative number. Because what is the reason? Why? This is very important question and also conceptual question. Why all the modern digital system uses two's complement method? You can do the argument that why should the digital computer should have the one's complement methodology, but this is the explanation. Let's say 0. If this is plus 0, this is minus 0. Okay. Now if you perform one's complement, this is in decimal. Okay, this is in decimal. So let's say in binary I have represented 4 bit, 4 zeros to 0 0 0 0 2. This is the 4-bit representation of 0, right? Okay or not?
Yes, sir.
If you have any problem, raise the doubt when you have any doubt. Okay, after discussing the whole thing, don't tell me that I don't understand the first thing what I told. Okay, now tell me it is okay.
Sir, we are
Now
represented. Sir, sir, we are representing
হ্যাঁ আমি
negative.
শুনছি বলে যাও
Sir, we are representing negative number with one. So if we represent negative zero, we should add a one there. Means leftmost
no
one.
I am just talking about zero, magnitude zero. So there is 4 zeros. The question comes that sign or not magnitude, 1 complement versus 2's complement. So 0 means I am representing 0 in 4 bit. Here also I am representing the 0 in 4 bit. This is the first step I did. তুমি এতদিন যখন 0 কে লিখছিলে, ধরো 5 plus 0, if you are going to add 5 plus 0, what you do? 5 means 101 and 0 is 000. তুমি কি নেগেটিভ নাম্বার লিখতে? হ্যাঁ কি না?
No.
So just wait for some time. So if I do 1's complement কোন সাইডে করব? The side I have written as negative 0. So 1 1 1 1. So what is 1 1 1 1? 1 1 1 1 is negative 0, right? Because I told that in 1's complement it is called as negative number. Now I am making the 2's complement of this one. So 2's complement of 0 means 1's complement is 1 1 1 1 plus 1. So what will be the result? Tell me.
Sir, 1 আর 4টে 0.
1 and 4 zeros, right? Now initially I told that how many bits I have. I have 4 bits. Now total how many bits is generated after 2's complement? 5 bits, right?
5 bits. Yeah.
So 5 bits cannot be occupied into the 4 bit area. So only these 4 bits will be consumed and these will be discarded, because there is no space for keeping this one. The one will be lost. Actually we will take that benefit. Now what we get? 2's complement. So 2's complement of plus 0 is 0 0 0 0. So what we get in 2's complement? In 2's complement what we get? Plus 0 is 0 0 0 0 and minus 0 is also 0 0 0 0. But in 1's complement what we get? Plus 0 is 0 0 0 0 and minus 0 is what? 4 ones, right? Up to this is clear or not?
Sir, can you repeat again, sir? This part.
আরেকবার repeat.
I have already shown to you this is 0. After that calculating the 1's complement, that is 1 1 1 1 toggling the bit. Okay, now I am saying that 1's complement is also used for negative number. So in 1's complement what I do? I have used plus 0 to 4 zeros. Okay, that is clear, because this is our initial
sir.
one, and minus 0 after 1 complementation done we get 4 ones. And in case of 2's complement what I start with? Plus 0 is 4 zeros, and after completion of the 2's complement what we get? We get 4 zeros as well. Now understood?
Yes, sir.
Now tell me, can we write in our mathematics, forget about the computers, can we write plus 0 equals to minus 0 in our mathematics?
Yes, sir.
It is true. Now
Yes.
if we uses 1's complement to represent a digital system, the problem will be plus 0 and minus 0 have the same different entity. In 0 we in our mathematics, in 0 if you put plus or minus there is no change, only the 2's complement offers the same. In 2's complement plus 0 and minus 0 have same magnitude, but in 1's complement method The magnitude has different with plus 0 and minus 0. Though the modern computers or any digital system actually runs on the concept of mathematics. So if the things is not supported in our mathematics, we cannot implement it the part into the digital system. Because our actual objective to build the computer to solve the mathematical problem. If the mathematical problem says that plus 0 and minus 0 are two different entity by any digital system, so this system will cannot sustain. So that's why all the modern digital computers uses choose complement methodology. Understood or not?
আচ্ছা
স্যার
স্যার, ডেসিমেলে শূন্যর কি বাইনারি 4টা শূন্য হয় বাইনারিতে?
চারটে নয়, 8টা শূন্য হতে পারে, 16টা হতে পারে, 32টা হতে পারে। ফর দিস ডেমনস্ট্রেশন পারপাসেস আই এম শোয়িং 4 zeros।
আচ্ছা
স্যার
আচ্ছা আচ্ছা।
বলছি টুস কমপ্লিমেন্টে যে ওয়ানটাকে ডিসকার্ড করলাম, ডিসকার্ড কেন করলাম? 8 বিটে কেন নিয়ে গেলাম না?
স্যার এটা আমারও কোশ্চেন, আমার মনে
Initially you have, suppose you have a computer which have a 8-bit of memory. So when you first time put zeros into the system, what it actually put? 8 zeros or 4 zeros?
স্যার 8 zeros।
Because all the remaining bits will be padded with 0. When we complement that one, so it will be 8 ones. After that, when you add extra one, it will be 1 after followed by 8 zeros. So why we will keep this extra one? You will change the hardware when your program is running. Is it possible? Yes or no?
স্যার আমার কোশ্চেনটা হচ্ছে, স্যার ওয়ানটাকে যে ডিসকার্ড করলাম, বাঁদিকে আমরা 3টে জিরোতে অ্যাড করে এটাকে 8 বিটে করে দিতে পারতাম। মানে ডিসকার্ড কি করে করবো তাহলে? তো ভ্যালুটা চেঞ্জ হয়ে গেল।
What I have said just now. What I have said just now.
স্যার ওই যে জিরোটাকে মানে আমি বললাম, আপনি বলছেন যে এই 4টে ওয়ার্ডটাকে 8টা ওয়ান করে দিয়ে ডান দিকে
আমি
জিরো
একবারও
জিরো।
বলিনি, তুমি তাহলে শুনতে ভুল করেছো। আমি বলেছি if my system having 8-bit memory, 8-bit memory, first time when I store 0, can you store 0 in 4-bit and can you blank it other 4-bit, or you will fill up with all 8 zeros to represent 0? First of all, tell me.
We will fill up all the zeros.
All the zeros. Now your program is running, you are performing the 2's complement. So after 8 zeros, 1's complement will be 8 ones.
Yes.
Then you perform extra 1 with this 8 ones. So what we finally get, you will get 1 followed by 8 zeros. Now tell me how you can change the hardware. Whenever you are downloading a 2 GB file and your memory is only 1.5 GB, you will increase your memory. Is it possible?
No sir.
So same thing is also here. The computer now a modern days computer actually works in 32 bits. I am demonstrating the things in 4-bit because I don't like to write 32 zeros in my skills. Understood?
Yes sir, understood.
So all the modern computers runs on 2's complement methodology. Because of only 2's complement methodology gives the same
sir.
magnitude of plus 0 and
স্যার একটা
minus
কথা
0.
বলার ছিল স্যার, জাস্ট আ মিনিট, সরি টু ইন্টারাপ্ট। আমাদের একজন বন্ধু সাহিল, ওর পাওয়ার কাট হয়ে গেছে বলে ও অ্যাকচুয়ালি অফ হয়ে গেছে, তো ওইটা আর কি আমরা অ্যাটেন্ডেন্সে কাউন্ট করে নেবো। হ্যাঁ
ও এখানে দেখে নিচ্ছি আমি।
হ্যাঁ স্যার, ও অফ হয়ে গেছে
ও
অ্যাকচুয়ালি, কারণ
জয়েন
ওর
ছিল স্যার,
পাওয়ার কাট হয়ে গেছে
পাওয়ার
হট করে। ও
কাটের জন্য
এক্ষুনি
পিসি থেকে ডিসকানেক্ট হয়ে গেছে, ফোন
হ্যাঁ
থেকে জয়েন করার ট্রাই করছে।
শোনো
Exactly,
শোনো, just one thing, let me tell. In my system, if you join for 1 minute or 30 seconds, your attendance will be counted.
Great,
So no
then
matter
sorted.
for this area. Okay.
Sorted sir. Okay.
So you can see that whether Sahil is present or not. I am seeing list. Shahil, where is Sahil?
So current has not joined in because he's got disconnected, but he was like 2 minutes back also.
He was his 2 minutes back also, so definitely he should present here. Okay, so in the at the end I will check. Sahil, tell the name. What Sahil, right?
Yes, yes, Sahil. Sahil, sir. Sahil.
Same name is also there in the meeting
Yes.
name as well. Right.
Yes, sir. So you will don't need the attendance from us because you're already taking the copy, right?
Yes, sir.
Okay, 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 okay.
Okay, now this is the reason that all the modern computer uses two's complement methodology, right? Any question for any discussion? Three methodology: sign, magnitude, ones, twos. So computers runs on two's complement methodology. এটা আজকে থেকে মাথার মধ্যে রেখে দাও।
স্যার এই যে টুস কমপ্লিমেন্ট মেথোডলজিতে কেন রান করে, এই জায়গাটা যে লাস্ট পার্টটা বললেন না যে ওইটা মানে 32 বিটসে রান করছে, ওই জায়গাটা একটু আরেকবার একটু বলবেন, আমি শুনেছি কিন্তু মানে ক্লিয়ার হয়নি ঠিক জায়গাটা।
Because when you store 4 in the computer, okay, so if I type 4 in anywhere, in notepad or it may be in word, anywhere, if I put 4, okay, then what will happen? The 4 will be stored into the binary, yes or no? Because computer only
Yes sir,
no
yes sir.
binary. Now in 4 will be stored in how many bits? How many bits? Because that will be the size of the supported bits by a computer. So nowadays computer store integers in 32 bits location. So that means you can put all these 32 ones to get the maximum value of integer that can be stored.
Sir,
Okay
in
sir, okay.
64 bit also.
Yes, 64 bit also, but in programming perspective, in C programming, when you run it, because C compilers only supports uh, integer to be 32 bits or 4 byte, because 1 byte equals to 8 bits, so 4 byte equals to 32 bits. And you are telling that operating system is 64 bits. That is different thing. Understood what I am saying?
Okay, sir. Okay, sir. Okay.
The operating system in nowadays available in two part, 32 bits and 64 bits. What is the meaning of that? In 64-bit computers, the instruction size, the instruction means whenever you are playing a music to the computer, that is an instruction. So the instruction will be converted into the binary. So it having some of the bits, maybe 8 bits, maybe 16 bits as per the design. So in 64-bit computer means if the instruction size in your computer is 16 bit, so that means at a time the computer can capture 4 instruction, each instruction having 16 bits, and in 32 bits machine it only capture 2 instruction. So that means 64 bit machine have a better range than the 32 bit machines. Understood?
Yes, I understand.
Okay, if I start the subtraction by today, it is difficult to complete with the stipulated time. So better to ask any doubt from what I have discussed for the last 4-5 days.
স্যার আই হ্যাভ কোশ্চেন স্যার। স্যার এই যে স্যার আপনি লিখেছেন স্যার, ওই যে টেবিলটা ছিল না প্লাস জিরো বেস 10, মানে একদম লাস্টে যে টেবিলটা করলাম, প্লাস জিরো বেস 10 আর মাইনাস জিরো এই বেস 10, এই প্লাস আর মাইনাসের জন্য আমরা ওয়ান আর জিরোটাকে এখানে ম্যাগনিটিউডে ধরছি বলে মানে ধরছি না।
No. Sign magnitude. Forget about sign magnitude. Sign magnitude what gets sorted for the first time. After that, one's complement, then two's complement comes.
আচ্ছা আচ্ছা,
Forget about sign magnitude part.
মানে এখানে শুধু মানে এতেই ধরছি, মানে প্লাস জিরো ইকুয়াল টু মাইনাস জিরো, এটা প্রুফ করার জন্য এটা
Yes,
করছি।
yes. Plus 0 equals to minus 0. I am going to prove. That's why in the top of the table, I have used to write that plus 0 and minus 0.
ঠিক আছে।
Okay. Any doubt from any portion of the computer? Today I will sort out this one. And one thing, in tomorrow when I will start the binary subtraction using two's complement methodology, never ask that what is two's complement, because the things has been sorted. I only write the rules and I will perform
Sir,
some
can you
examples.
explain the complement portion? I just for
So
power
what
cut,
is
I'm just
complement?
disconnected.
Complement is different. Complement is the opposite in the English word. So if we are talking about complement of 0, the complement result will be 1. Complement of 1 is 0. So one's complement means each bit will be toggled. So here it is written 4 zeros. So after performing the ones complement, that means all the bits will be toggled. So 0 becomes 1 and 1 becomes 0s. So how many bits are there? 4 bits are being present. Out of them, all are zeros. So when we do toggle, what we get? All ones. So that is the first complement or the ones complement. When we do the second complement, the rule is to, first of all, we have to find the ones complement. After that, we need to add a 1 to that ones complement to get the twos complement. That is the rule. So I am showing you another example. If you unnecessary, never unmute yourself.
Saurabh, we can't hear you. Your voice is breaking up, Saurabh.
His
So
network is not good, I think.
probably maybe. Saurabh, if you want to say something, actually your voice is completely breaking. So you can write in short in the chat. And so please unmute yourself, mute yourself. So what I am writing 5. So 5 means 101. So if I am performing one's complement of 5, what I get? 0, 1 becomes 0, 0 becomes 1, and 1 becomes 0. So what we get? 0, 1, 0. If I want to perform 2's complement is nothing but 1's complement plus 1. So 1's complement is 0, 1, 0. I have adding 1. So 0, 1. Understood?
Yes,
The
sir.
complement part?
Yes, sir.
Even now you can tell me. So what is this? This is the equivalent of minus 5. No issue, because in our mathematics minus 5 and plus 5 is two different entity. In binary representation it is 101, and in binary representation of minus 5 is 011. So they are different. So no issue in that cases. But plus 0 and minus 0 should have the same values. So actually 2's complement offers that same. So that's why we are using 2's complement.
Sir, that means by using 2's complement, that is negative number. Means 5 base 10, 10's 2 complement is negative 5.
Yes, as computer understand.
Okay, sir.
If you put minus 5 into the computer first convert the binary of 5, after that do the complements, choose complement of that binary bit and store the remaining binary bit as 0, 1, 0, 1, 1, and in the next time when you fetch that value, computer will display the minus 5 as compared to 0, 1, 1. Okay?
Okay, sir. Understand.
স্যার আরেকটা কোশ্চেন ছিল স্যার, এই যে স্যার 011 এটা তো -5 স্যার, -5 তাহলে স্যার 4 বিটের মধ্যে স্যার কিভাবে সেভ হবে? ওই প্রথম যে সাইনের জন্য যে ব্লকটা থাকে ওটা কি
No,
1
no, no,
হবে না
no.
0 হবে?
Sign magnitude is a different thing. Two's complement is a different thing.
ওকে স্যার, তাহলে কি স্যার ওটা 0 হবে ওখানে?
No, actually the 5 will not store in 3 bit. I have already told that 5 will be stored in 32 bits. And the operation will be same what I am saying.
ওকে স্যার।
If you want that I write these 32 bits to represent 5, then it is very difficult to me to count these all zeros before after that toggling. It will take time. That's why I am always represent it by using 4 bit. That is for the representation or to demonstrate the thing what happening, but actually the things will happen in 32 bits. So if you can understand it by 4 bit, you can do it by 32 bits by padding extra zeros before. তুমি যদি কেউ 100 লিখতে বলো, if someone is saying to you to write 100 in your copy, just a minute. If someone tell you to write 100 in your copy, so you have many options to write 100. You can directly write 100 in 3 bit, you can write 100 in 5 bit, or you can write 100 in 8 bit, like
Sir,
that. Just a
sir,
minute. Just a minute. You can write 100, someone can write 100, someone can write 100. No issue. এবার বলো কি বলছো?
স্যার বলছি স্যার সাইন যে সাইন ম্যাগনিটিউডটা স্যার শেখালেন, ওই সাইন ম্যাগনিটিউড আর এইটা মানে মানে -5টাকে সাইন ম্যাগনিটিউডে আমি যদি রিপ্রেজেন্ট করি তাহলে ওটাকে বলবো 1101।
Look, one thing, sign magnitude is there. Sign magnitude is there. But computer uses 2's complement method to represent the negative number. Okay? But
Okay.
the sign magnitude is also be preserved by using 2's complement method. Sign magnitude is there. But as of your standard, it is very difficult to understand. Those who are doing the CSE, there is a subject of computer organization. There is a format IEEE 754 where you will learn the whole thing. This is the preliminary things. In ISHI computer architecture in 5th semester, you will learn the same thing. This is the preliminary part. I told you this is the 3 different methodology to represent the negative number. The primary motto to tell the everything, because we are going to learn the subtraction. That's it. Don't think in deeper. Understood?
ওকে স্যার।
Sir, hello.
I'm listening.
Sir, +0 and -0 get a same binary number, but +5 -5 get a different binary number.
তো in +5 তুমি যদি এরকম ম্যাথে লিখতে পারো, এটা সমান লেখা যায় না, এটা এরকম লেখো, কোনটা লেখো?
No, sir, it is different.
No, in decimal it is different. Definitely in binary it should be different. Otherwise, how computer can recognize which one is plus and which one is minus? This is a very simple concept. Why you people are taking it very tough? This is a very simple concept. 0 0 plus 0 minus 0 is same, so their magnitude should be looks like same in binary. The pattern should be same. But in case of +0 minus +5 minus 5, though it is different in the decimal, looks like different, values are different, we are performing in different operation. In binary, the pattern should be different. In binary, there is no sign. We have only the patterns of zeros and ones. So the pattern must be different in case of +5 and -5. Right?
Yes, sir.
Okay, so okay, tell me.
স্যার বলছি তাহলে সাইন ম্যাগনিটিউড ইউজ করে কম্পিউটার কি মানে -5কে রিপ্রেজেন্ট করে না, এরকম ভাবেই রিপ্রেজেন্ট করবে 2's complement
Computer
দিয়ে?
2's complement representation করে, sign magnitude also be preserved in case of 2's complement.
ওকে স্যার।
As of now, you only know the gist of this class. One's complement means toggling the bit. Two's complement means one's complement +1. This thing is required for tomorrow to discuss the subtraction.
So we'll be getting the class recording today itself, right?
Yeah,
For this
yeah,
one?
yeah. In late night you will get.
No problem, sir. Thank you.
In every class, if I forget to miss the click
I
the
will call
recording
you.
button, that is different. Otherwise, you will get there.
Okay, sir.
Okay, as of today is okay, and you may leave.
Okay, sir.
Okay, sir. Thank you.
Okay, sir. Thanks a lot.
Okay, sir.
Thank you.
Okay, sir.